containerization concept, and then we have introduced container orchestrator. So to implement the containerization concept, we will be using the Docker as a platform. So there are again many tools are available, but Docker is the most popular one. We are going to use it. And then to implement the container orchestrator, we have again various tools, but the popular tool is Kubernetes. So now let us understand what is physical server and what are the challenges which are exist with respect to this physical server. So for that, let me go to this presentation. Okay, so just assume physical server as your laptop. So if you see your laptop, right, you have hardware, and on top of that, you will be installing the operating system that may be Windows or Linux or Mac. So based on the operating system you are interested, you are installing that operating system on top of this infra, and then you will be running multiple application on this operating system. So operating system is basically a bridge which help us to connect the application to the infrastructure. So again, what is infrastructure here? So infra is basically having all the hardware resource. So that is basically RAM. So it include RAM, that is basically related to the memory or network components or storage. So which all comes under infrastructure only. So on top of that, you will be installing particular OS that is you are interested in. So let us take the Windows operating system, or if you are interested towards Linux. So mostly in the production we will go with the Linux, but for the example I am going to take the Windows. So as I explained about the OS, right? OS is basically bridge the gap between application and the hardware. Application, when it needs the resource, it will communicate with this Windows OS, and then it will access all the resource which is able to run the application. So on top of this, you will have application. So just assume here in this particular structure, if you are seeing, we can only use the single operating system, that is Windows or Linux or the Mac OS. So you can't install multiple OS on the single infra. So when you are using the physical server concept, then you will only deal with single OS. You can't deal with the multiple OS. So that is one disadvantage we found here, is that single OS. So the next disadvantage is that, for example, the application is running on this Windows OS, and then you have, for example, 100 GB memory and 100 CPU, for example. Now the application which is running on this Windows, it is only using the 50 GB and 50 CPU. So now there is a underutilization is happening. That means the resource is not completely utilized, whatever you allocated for this particular application to run. So just compare this with your laptop, and then you will understand how physical server works. But again, if it is a single laptop, it doesn't make sense. But when you are in production, you will be running your application on the multiple servers. That means you have this physical server, whatever the stack which I have provided here, it will be like 100 so the stacks you will be creating, on top of that you will be running the application. So now there is a underutilization of the resource. That means it is not properly utilizing the 100 GB and 100 CPU, because you are paying the money for buying all this hardware, but it is not completely utilizing all the hardware which you have allocated for this application. Then it is basically underutilizing all the resource which I have provided. So now you can ask me the question, if this application is not completely utilizing, I can deploy another application, or I can scale up the same application in the single infra only. So then, for example, this application 2 you are using on the same infra. So that is, for example, this you can take it as application 1. So now you want to deploy this application 2 on the same infra, that is, so here you want to allocate some resource to this application to run, but this application needs more resource other than 50 GB and 50 CPU. So it needs now 100 GB and 100 CPU. So now it is not sufficient to run this application on this infra, because only the available resource is 50 GB and 50 CPU. So it is already 50 GB and 50 CPU, it's already utilized by application 1. So the other 50 GB and 50 CPU is left. So now I want to allocate that particular resource to this application 2. But application 2 is again requiring this 100 GB, 100 CPU. So this infra is not sufficient. So then what you will do, again you will buy another infra. So that is, you will buy another infrastructure setup, and then you will install the same OS where the particular application wants to run. For example, it is also Windows OS. And then so now here you allocated or deploy this application to on this infra. So now what was the issue again? So you have to invest more money to buy this set of infra again, and you have to configure with respect to the operating system, and then you have to deploy all the application related dependencies and also along with the application. So this is again time consuming process. This is not easy. And one more thing is, even if you deploy the same application to on the same infra, so that is the first infra which you have bought, and then application 2 is, for example, it is utilizing the 50 GB and 50 CPU only. But sometimes when application is become complex, this application 1, it demands more. That is, instead of 50 GB and 50 CPU, it is now requesting for 60 GB and 60 CPU. So now the application 2, even it is needing the 50 GB and 50 CPU, it is not getting the sufficient resource. So this we call it as a resource contention. So let me type it here. So what is basically resource contention means, when you are running multiple application on the single infra, but application 1 is consuming lot of resource and application 2 is not able to run on the same infra, so then it leads to the resource contention. But when you have two application and application 1 is not completely utilized your resource, then we call it as a underutilization of resource, and you will be mostly dealing with single OS on the server. And also when you need another set of infra to deploy another application, then you have to invest more money to buy this hardware, that is RAM, network, storage, and also you have to configure everything on top of that. So that may be any OS you are interested in, and then you have to deploy the application. So this is again scalability wise, that means you are increasing the infrastructure wise as well as you are scaling the application. So why you need to scale the application, right? So let us take the Amazon as an example. So Amazon during the festival season, so more user comes in, and because the offer is more during that season, so more people comes in to access the website, and the load is also increased in the website. So now to handle all the user requests, you have to increase the infra, because in the single infra 100 GB 100 CPU is not sufficient to handle it. So then you have to do the scalability. So when you are doing the scalability, this is not an easy task, because you have to buy everything and you have to install everything. So this will take around, for example, 6 months, because infra is not available directly within the organization. You have to go to the particular vendor, so it may be HP or uh, any other company which is providing the server to you. So those people you want to contact, and then you have to buy the hardware. So this was the scenario. Even the cloud provider came into the picture. This is the challenges we faced. And then in order to solve all these challenges, we have introduced this virtual machine. So now let me explain this. Okay. So let us go back to the presentation, and then, so whatever I have explained so far, so you will have single operating system, and then one application is not isolated from the another application. So when application one is consuming lot of resource of your infra, then another application is not able to get that resource. It will lead to the resource contention. And then running multiple application or the service on the separate physical servers, you have to invest more money to buy the hardware and to configure everything. And also you have to manage whenever there is a patch is required for the OS, or whenever you want to replace some hardware component, everything you have to take care of it. So, and also scaling up and scaling down is not easy based on the demands from the user. So these are the challenges we faced with respect to the physical server. Sorry. So now we have introduced one solution to solve all the challenges which is there in the physical server. So that is basically virtual machine. So what actually virtual machine is, you have infrastructure, and also you can have operating system. On top of that, you can install hypervisor. So this is the hypervisor is a tool which is provided from one of the company who maintain this virtualization software. And then on top of this, you will be creating a virtual machine. So it may be based on the infrastructure you have, you can create a number of virtual machine. So currently we have, for example, 3 virtual machine here. So what is virtual machine again? So virtual machine is tightly coupled with the guest operating system. That means apart from what you have as a host operating system, that means for example, you have installed Windows in the beginning when you buy the laptop, and then you install this hypervisor, and then you install or create this virtual machine. And each virtual machine you can like allocate some resource and also OS you want to work with. For example, you have Windows on the host operating system and you want to work with Linux. So now it is possible, you can create the virtual machine and you can configure the virtual machine to use the Linux operating system. Similar way, you can also use the Mac operating system or any other operating system or Linux distribution you want to work with. So create virtual machine, attach operating system, and then you can able to run the application. So this is what the virtual machine. It is tightly coupled with the guest operating system. So now, as I mentioned, there is a host operating system and there is a guest operating system. So when you talk about host operating system, that is, when you buy the laptop, you will be installing some OS so that it will communicate to the hardware to run your application. So again, hypervisor is one of the application which is provided by some other organization you want to run on your laptop. So now hypervisor also wants to use the hardware. So when also you need some operating system to run, right? So maybe you are using the Windows here. So as I mentioned, when you talk about the virtual machine, so then you will have the guest operating system. So based on the interest, you can attach operating system and you can work with. So as I mentioned, a virtual machine is tightly coupled with the guest operating system. So that's why it is a heavy. That means when you want to port this or when you want to export this particular virtual machine on any other machine apart from this infrastructure, or you want to do scalability, again, whatever I explained with respect to the physical server, that is again followed here for the scalability. So when you want to do the scalability on the different infrastructure, then you have to consider the underlying operating system and also underlying hypervisor. So on the same hypervisor only you have to create the virtual machine and you have to run the particular application. So this is one of the limitation in the virtual machine. And also, for example, you are allocate some resource for this particular virtual machine, but it is not completely utilizing again. So that will lead to underutilization, or it is lead to the resource inefficiency. And VMs, when you want to start, right, if you are already experienced with the virtual machine, you will face this kind of issue. When it is booting up, it will take longer time. So that means when you want to run your application, that time it definitely take lot of time, and to start your application itself. So that is again one of the disadvantage you will find with respect to this virtual machine. And then VMs again tightly coupled with the operating system. So operating system also, it is going to use some resource from your infrastructure. So again, application is not able to get the sufficient resource to run it. So that means here, so here, as you can see, there is an operating system for this virtual machine as well. So it also has some task, right, to do. Then it is also going to use some infra. So it is not completely allocate the infrastructure to the application. So some part of the resource is going to be used by this guest operating system as well. So now, so again, I mentioned, so because it is tightly coupled with the OS operating system, so that's why scaling is also very difficult when you want to like run that particular application or scale that application based on the demand to another infra. Okay, so now to solve all these challenges with respect to the virtual machine, we have introduced the containerization concept. So now let us understand how we can implement the containerization concept. So again, you have the same infra and you will have the host operating system. On top of that, instead of hypervisor, you will be using the Docker platform. So what Docker is offering to you, it is a platform where you can create a multiple containers. Okay. So what is container again? It is a bundle of application libraries required to run your application and the minimum system dependencies. That means, so when you develop the application, there are some dependencies which is necessary for running this application. For example, in the Amazon itself, there is a website which you can see, right? When you want to order, so then you will go to the amazon.com and then you will start ordering and do the payment and everything gets processed. So how this application is working, even when you see the code of this amazon.com, then you will see lot of dependencies which is needed to run this application. So that is what actually the application libraries here, and to run your application and the minimum system dependencies which provide the isolation between the containers. So as we see here with respect to the virtual machine, so virtual machine is tightly coupled with its own operating system. It will not provide or any trouble to this virtual machine where app B is running. So it is completely isolated. Similar way, here also in the containerization concept, here also we are introducing the isolation. What is isolation again? So this app A should not trouble the app B. So in previous scenario, when we discuss about the physical server, application 1 is trouble the application 2 when it is using the resources. But here it is not happening because we have this isolation. So here also we are using the Linux concept only. So you will study when we comes to the Docker concept. And it is, as you can see in the diagram, so this API is not tightly coupled with the any operating system separately, but it is using the host operating system only. That means all the containers is depends on the host operating system and the underlying infrastructure. That means these containers become lightweight now. So compared to VMs. So now this containers will provide the lightweight feature. So what is lightweight? It is not tightly coupled with any operating system. So it will directly use the host operating system and underlying infrastructure. So due to this feature, you can easily ship this particular container to anywhere on the different machine. So for example, I am working on my Windows machine. I have just installed the Docker, and then I have created this container, and then this container I can push it to, or this container will have the image. Again, that image I can push it to particular repository. So anyone can use that particular image and create the container out of it. So this we will see again how Docker lifecycle will work in the course. But this container is basically using the host operating system, and it is easily portable. So there are, again, to implement this containerization concept, we have various tools, but the popular one is Docker. And the Docker Enterprise is the enterprise edition, where in the organization level they don't want to make it, or they don't want to use the public edition, so then they will go with the enterprise edition for the security reason. So currently we are going to discuss about the Docker. So again, what is Docker? It is just a platform where you will be implementing the containerization concept. So that it is a simplified definition, and Docker has the CLI, user friendly CLI. You can interact with the Docker daemon, that is Docker host, and then you can create an image, and you can build that particular images, and from that image you can create the containers. So we will understand all these details when we get into the course. But for now, this is the Docker. It is a platform where you are creating the containers so that you can understand easily. Okay, so now this is the Docker architecture. You can visualize so that you will be able to understand what actually Docker is. So Docker is basically consists of Docker client and Docker host and the Docker registry. So what is Docker client and why we need it? So when you want to communicate with the Docker, then as a user, I want to communicate with the Docker host. How can I do that? Using the Docker Docker CLI commands. So that is basically Docker build, Docker pull, and Docker run. And you will have a Docker host as a separate component in the Docker itself, and where you will have the Docker daemon. So Docker daemon is a process which is running inside the host. It will help us to create the images. From the images, you can able to create the containers, and you will also have the registry. In the registry, again, we have two important things. One is public registry, and one is private registry. In most of the organization level, we mostly go with the private registry, but um, for the normal work or for the practice, we will go with the public registry. So this is the commands which we are going to use, and these are the API requests we are going to make to the Docker daemon. And Docker daemon is a simple process. It will help us to create the image, and from the image, when you want to create a container, you will be running the Docker run command. So now let us understand what are the challenges with respect to this Docker. Okay, so as I mentioned, Docker has many containers. So when you want to manage all these containers, you need a significant manual effort. For example, as I'm in one of the team, I want to manage all the containers, whether all the containers where my application is running, it is healthy or not. I want to check it out. So now one container is somehow it crashed due to some reason. That means it is not able to get some sufficient resource, so that's why it is not able to run the application itself. Then as a team member, I have to go and check all the containers who are healthy and not healthy. So then I will understand that, okay, this containers is not running properly, so I want to check it out why it is not running. So you have to troubleshoot that, and you have to resolve the issues by putting the manual effort. So this is one of the challenges we faced with respect to the Docker. So Docker is just like a platform where you are creating more containers, but it is not going to provide the environment to maintain all the containers for you. So again, as I mentioned, when you are working towards production side, you will do the deployment, scalability, and load balancing and self-healing features. So these are the common enterprise standards you will see. These are the features are not directly fulfilled by the Docker. So that's why we are not able to use the Docker in the production directly, but to create containers and provide the platform to maintain all the images, we are mostly going with the Docker. So now to solve all these challenges, that is, instead of putting more manual effort and writing script to automate some task, instead of that, there is a powerful tool which is available in the market, that is container orchestrator. So again, in the container orchestrator, we have different tools, that is Kubernetes, Docker Swarm, and the OpenShift. But Kubernetes is the most popular one used because it is offering some advanced feature other than these container orchestrator. So that's why we are going to use the Kubernetes. So let us understand what are the features which is providing from the Kubernetes. Okay. So the very first feature is auto healing. That is, in the Kubernetes environment, if something is not working with respect to any resource, so in Kubernetes again we have different resource to deal with. So those things we will be discussing in the course. But when something is not happening properly, then Kubernetes will auto detect that, and then it will heal from that particular issue, or it will minimize that issue, or it will resolve that particular issue. So that is the auto healing feature. And then auto scaling, using the Kubernetes resource, it is able to auto scale up. So there is a HPA concept, so where it helps us to scale up the Kubernetes resources. So that is one of the feature we can found from the Kubernetes. And then high availability. So high availability is very much needed when you are talking about the reliability side. So even most user using your application, they demands high availability because they don't want to face any downtime in your application. So that is how the high availability is maintained by the Kubernetes. And then it is having the cluster. So that means you are setting up the Kubernetes using the master and the node architecture, where this is the sufficient what the way of managing all the worker in the worker node specifically, and master node will going to teach everything to the worker node to act accordingly. So that will done by the entire cluster setup. So this is how entire Kubernetes is going to provide all the feature for us to maintain all the enterprise standards. So this what we discussed, right? So this we call it as a enterprise standards. So that means in any organization, if you want to work with any tools, so if that particular tool is providing all these features, then it is a powerful tool, and also it can be used for the production or any other purpose. So again, apart from all these features, Kubernetes is also providing this capability to extend that features apart from what actually it is providing. So you can build the logic to extend that, and you can work accordingly for your application. So that is extensibility here. So these are the some of the enterprise standards which are fulfilled by the Kubernetes, not done by any other tools. So that's why Kubernetes is the most popular tool we are using in the current industry, or also in any organization. So why you have to study the Kubernetes again? So many job roles, if you are seeing right in the JD, so this Kubernetes tool is the must having or it is having must tool, for example, it may be mentioned in any of the section. And if you are definitely trying for DevOps SRE roles, so then it is definitely useful. And also, even if you are trying for any development roles also, so there will be a requirement of the Kubernetes. And again, in the Kubernetes, you have this Kubernetes operator concept. So this will help us to extend the Kubernetes capabilities. So there you will need the development side knowledge as well. And also you need to have the Kubernetes knowledge as well. So this is again one of the trending topic where you will find uh, so the Kubernetes as an importance. So I hope all this clear. If any questions, you can ask me. Otherwise, we can go with the course content. Any questions here? Sorry, I had some throat infection. So while talking, I was coughed, right? So sorry for that. Any questions here? So basically how this Kubernetes tool come into picture, that I have explained. So physical server has some challenges, then we introduce the virtual machine, and finally we come up with the containerization concept, and then we have introduced the container orchestrator. So in the physical server, basically as I mentioned, it has a single host, and we have the resource contention problem and underutilization of resource. So these are again leads to the resource inefficiency. And then we have introduced this virtual machine where you bring the isolation between the application, and every application is tightly coupled with the operating system, but still it is an heavy because as I mentioned, it is having its own operating system. When you want to scale up that particular application which is running on that operating system, it is again difficult. You have to consider all the underlying hypervisor and also the infra which is allocated. And then we have introduced this containerization concept with the help of this Docker platform, where you will be creating multiple containers inside the containers, where you will be running multiple or applications. And it is not tightly coupled with the operating system, but it has its own isolation. Container A, it is not going to trouble the container B. So that is the what advantage we'll get from this containerization concept. And then with the help of Docker, we can't able to manage everything with respect to this container health or scalability or deployment. It is not in easy. You have to write some manual script, and also you have to provide some custom solution. So instead of that, there is a powerful tool which is available for maintaining all the containers, so that we call it as a Kubernetes here. So Kubernetes, what it is providing, all these enterprise standards which is not provided from the Docker itself. So that is auto healing. So when something is not working accordingly, so then it will auto detect that and it will heal from that. And then auto scaling, so basically when you need to scale up the resource, so then it will automatically do that. So we will discuss how this auto scaling will work in the Kubernetes. And then high availability, so this is again demand from the user. You have to make sure that your application is available all the time. And then it has a cluster architecture, where you will maintain the master and the node architecture, where the load is not going on the single node, but it is distributed. So that is what the cluster. And the extensibility, so apart from what feature is providing from the Kubernetes, you can also extend the capabilities of Kubernetes. Some of the feature you can implement for your application. So that is all about the Kubernetes evolution. Okay, so if no question, then we'll go to the Kubernetes course content.
Yeah, Rohini.
Okay, so yes.
So it's like what kind of application you are going to deploy in Kubernetes?
Yeah, so I will show that, because in every resource we have some basic application to deploy, and in finally we are going to show some very specific application to deploy. So for example, in the pod or deployment, we will be specifying some like simple application in initially to understand, and then if you go to the so if you go to this monitoring part, right? So to again to monitor the cluster when you deploy the application using Prometheus and Grafana, so there I will be using some end-to-end application to showcase how when you deploy the application inside the cluster, how you can monitor the cluster status from the Prometheus and Grafana. But for various resources which I have mentioned here with respect to the Kubernetes, I'm going to specify or I'm going to demo the very simple example which you can understand initially. And if you want some more example, then I can also add it here. It's not a problem. But as the course mentioned, it is beginner to a master level. So that's why I keep the simple things here, but I can also add some more example if you guys want it.
It's a Java-based application you are going to show us.
Yes, for this Prometheus and
Straightforward.
Grafana, I'm going to show the same thing. But most of the running application you will see in the normal organization, right? So you will mostly use all these web server concept as well, that is Nginx and different applications as well. So those things we will be discussed during the session. So again, Nginx, which I am going to tell right here. So that is also one of the use case where you will be using this Nginx in your production applications as well. Okay, any other questions? Okay, if no question, you can ask later. If any question, also you can type it in chat. So we'll go through the Kubernetes course content first, and then if you have any question, you can ask. So basically, to understand the Kubernetes, as I mentioned, the evolution when you see, right, before Kubernetes, we have the Docker. So once you understand at least basic concept regarding the Docker, then you can easily understand Kubernetes. What actually happening in the Kubernetes? What are the advantages you will get from the Kubernetes, which is not get from the Docker? So those things if you want to differentiate, then basic knowledge of Docker is needed. But even if you don't have any knowledge on Docker, still in this course I'm going to cover whatever the basic which is needed for understanding the Kubernetes. So that those concepts I will be clearing in the I will be explaining during the first few sessions, and then we'll go with the Kubernetes. So firstly, we will go with the Kubernetes architecture and the components, because it is very important to understand how the communication is happening inside the Kubernetes cluster, and what are the components are available, and what are the purpose why those components are exist in the Kubernetes cluster. So these are the detailed like components I will be explaining in detail, so that when you come to this installation part, you will get to know, okay, these are the component I need to install on the cluster so that I can run the Kubernetes. So those things are very necessary to understand the Kubernetes itself. And in the Kubernetes, again, we have various components. When you are trying to install, you will be using some of the tool, that is Kubedium, kubectl, kubelet. So this we will discuss what is the purpose of it, and even during the installation I will explain each and every step what actually it is doing. And then we have various resource. So these are the resource which are helpful to achieve the enterprise standards. So first, the basic resource we have is pod resource. In pod, again, we will discuss what is pod and container, and pod networking and storage, and pod lifecycle, and pod creation with init container, and how you can allocate the resource for this particular pod, so that it will not consume lot of resource from your cluster also. And then we will deploy the application using the Nginx. with the single container in pod, and also we will see how you can create multi containers in a single pod itself. So we usually follow the single container in a pod, but there are some use case where you need to provide the multi containers and you have to deploy the pod. So those things we will see with the scenarios. For each things I will be explaining in the demo, or also I will be explaining theory plus the practical sessions. And then, so pod is basic resource. On top of that, you will be creating this deployment resource. That means it is a wrapper to this pod. So deployment is providing some advanced level capabilities apart from the pod resource. So those things we will see what are the advantage we are getting from the deployment, and it is not providing from the pod itself. And so deployment is a main resource which we are going to use for the scalability. So those things we will see, and also we will deploy the application, and how the deployment will work with a real life example. And also during the demo I will explain how this demo or how this deployment will work, so when you deploy the entire application. So those things we will see. And then, so there are some strategies are there. So when you want to roll back, rolling updates and recreate, so rollout history, how you can do that. So those are the option which is provided from the deployment again. So those we will see with the help of commands. And then once you have a resource from the Kubernetes, to handle all the resources you need an important component again, that is basically controller. So in the controller again we have different controllers for the different purpose. So currently here I mentioned the replication controller and replica set controller, but I will show what are the controllers available and how it helps us to manage just the different resource. And then we have daemon set resource. It is similar to deployment, but it has some different purpose, so that we will discuss. So each again we will discuss the theory concept and as well as the practical demo sessions as well. And then stateful resource. So deployment, daemon set, stateful set, these are comes under one category, and it will use for the different purpose, but they are and comes under the same category. So those things we will discuss. And then we have the storage. So again, storage is very important component when you are dealing with any application data or database data or any logs you want to store it as a permanent storage. Then you have to definitely understand the storage. Storage is a critical component for any application. And then we have networking. So networking again, it's a very important to build the communication or establish the communication within the cluster or outside the cluster for the user to access your application, or if you want to restrict the access from the outside world and only within your organization you want to access it. So those are the things comes under networking configuration. And then config map and secret. So basically you will deal with lot of sensitive data in your application. You want to keep all the sensitive data as a separate, so then you will be using the secret. Config map, it's just like any configuration data you want to store for your application, then you will go with the config map. So again, as I mentioned, I'm just giving an idea what are the resources are available, but every resource we will be seeing the demos as well with the theory concept. And then we have ingress. So this is the ingress which help us to root or access the particular application which is running as a pod resource or deployment resource or any resource inside the cluster. It should be accessible from outside. Then you will be mostly using this ingress resource, and this you will be seeing with the ingress controller how we can deploy the ingress controller, and how we can establish the communication from the external world. Okay. And then scheduling in Kubernetes. So scheduling is very important again. So there is a auto scheduling is happening inside the cluster. When you want to create a particular application as a pod, then you don't need to specify you want to like in which node you want to allocate this particular resource, but Kubernetes is deciding that factor, and wherever the resource is available, so based on the availability it is going to allocate the particular resource on that particular node. So I will explain what is node again and pod, so the difference between them, so in the course. So these again very important factor in terms of scheduling. And then container health check. So again, every time the Kubernetes is doing for us, but if you want to see how things are working with respect to the container, but you are not going to do anything, Kubernetes itself is going to take care of all the things, but you want to see with respect to the container health, then you will use the liveness probe and readiness probe. So that will help us to understand whether container is ready or not. So those are the things we will discuss with the demo. And then we have jobs and cron jobs. So these are again some resource which are present in the Kubernetes. Okay, and then we have authentication and authorization. So because it is very important when you want to access some resource in the cluster, whether you have all the privileges or not. If you have all the privileges, then only you will get the access. Otherwise, you don't get the access. This is how the Kubernetes cluster will manage all the authorization and the authentication. So we will see all this with the examples as well. And then, as I mentioned, so Kubernetes operator, it is again providing the extensibility where uh, you are going to build your operator, and this will going to provide the extra capability to handle your application apart from what Kubernetes is providing to us. So that is one of the topic again which comes under Kubernetes. And so Kubernetes operator, it includes a custom resource definition, and operator SDK framework. So I will explain in detail how you can build the operator and how you can provide the logic and how you can provide the operator SDK framework. And because this framework which help us to build the operator from the scratch, so you don't need to develop some code, but it is not, it is already available from the framework. So you have to build the, or you have to mainly focusing on the business logic. So those are the things we will see in the practical session. Okay, and then as I mentioned, monitoring is also important. Whether you are in the cluster, all the containers are all, or for example, all the resources are healthy or not, you want to check it out. Then you will be using some Prometheus and Grafana as a tool to connect with this cluster where your application is running, and then you will be monitoring all the cluster status. And then you have troubleshooting. So definitely you will say, face many issues in the Kubernetes cluster. You want to make sure that at least you get an idea how the common problems will arise from the Kubernetes, so that whenever you are in the organization, you will get to know, okay, these are the things like commonly occurred problems, so these are the solution I need to provide. So again, there are some like issues rises from directly from the production, or some will be during the development itself you will be facing lot of issues. So those are the things we will be discussing, and how you can provide the solution to those problems. So those things we will discuss in the troubleshooting. And then dashboard. So basically, Kubernetes is also providing the UI. It is also it is not only providing the CLI, but it is also providing the UI where you can visualize where exactly Kubernetes is running, and what are the components are present, and how many resources are running, and what are the resources are present. So those are the things you can visualize in the UI itself. So instead of CLI or a command line tool, you are going to use it. So instead of that, you can also explore UI side as well. So that is basically the dashboard. And then we have the Helm. So Helm is a package manager which help us to package everything with related to the Kubernetes manifest. So in the Kubernetes, what we usually do is we will write the manifest to create the different resources. It may be pod, it may be deployment, or it may be service, config, map, secret, whatever the resource you are going to create. So that will be basically manifest. So all these manifest, you don't need to every time run the some CLI commands, and you have to create those resources on the cluster. That is not needed. If you package everything, all the manifest using the Helm, then Helm will provide all the capabilities to deploy that particular manifest, or in the manifest again you will be specifying all the application related things. So accordingly it will deploy your application on the cluster in the one go. So that is actually the Helm package manager. So again, in the Helm, we have the Helm CLI. Various commands will be provided from the Helm CLI. You are going to use it and you will deploy the entire applications. So these are like what course is offered to you. So from the beginner to advanced level, all the concept which is covered here. And I hope the course content wise it is clear, or any questions you can ask. Sorry, I was not bit well today, so sorry for that. So any questions you have, you can ask me.
Yeah, Rohini, Naveen here. So, are you going to deploy any microservices in the in the container with the help of this Kubernetes?
Yes. So we have this sock shop application. So I will be using that sock shop application while demoing. So again, it is a simple order application where you have multiple components, and we will see when some of the components it's not working in the microservice application. Also, you will see, for example, order pod is not working. Then you can't able to access the order from the application. So those are the scenario we are going to see while troubleshooting as well. So yeah, I will be using the sock shop application.
It was developed on Java.
No, I actually as an SRE I was mostly work with the Python and Golang, so I did not work with Java. Yeah, for basically for the Kubernetes operator, you have to have the knowledge on Golang. So Python for the scripting I have used. So Golang is for the development purpose, that is to develop the Kubernetes operator from the scratch.
So we
I
need
will explain.
Golang also.
Yeah, basically to understand the Kubernetes itself, even if you see the Kubernetes itself, right? So entire project which is built using the Golang. If you are extending the capabilities of Kubernetes, then you have to make sure that you are at least aware of what is Golang and the syntax wise. Yes. But it is again not compulsory, because I'm not going to show the entire thing in the Kubernetes operator, but this is the possibility you can use for developing the some of the application feature. If you want to fulfill it, it is not directly provided from the Kubernetes, then you can use this concept. But again, in the organization, if you like see some of the JDs, right, they are preferably going with this Kubernetes operator concept. Even they are not asking you about the Kubernetes, but they are directly mentioning this Kubernetes operator. And you want to build this Kubernetes operator from scratch, then you have to have the good knowledge on Golang. But yeah, for this course, it is not necessary again.
Okay, for Kubernetes operator, there only we'll use this Golang, right? You are telling.
Yes, yes, yes. Because Kubernetes is built using the Golang, you are extending the capabilities of Kubernetes using the Kubernetes operator concept. That means if you want to build something, then with the same like whatever the capabilities is providing from the Kubernetes, you are just using the language to develop the logic. That's it.
Okay, and I have one more question. So you are telling about
Yes,
pod resource and deployment resource. So
yes.
both are doing the same job, or the role is same, or it will be different.
So pod is basically having the like it is a single replica. You can take it as like there is a one application which is running as a pod. But if you take deployment, right, so there you can scale that particular pod. That means it is a replica of pod. Instead of single pod, it is providing this multiple replicas of pod, so that you are ensuring the high availability. So in organization level, if you talk about, right, so then you will not directly deal with the pod because it is not providing the high availability feature. Even this pod gets failed, so then it is something related to the container only. So that means you can't uh, like restart this entire pod, or you want to create the new pod itself. So you have to check it again manually, and you have to do the creation of the container. But comes to the deployment thing, so if something goes wrong with the replica of pod, then there is a controller which is available in the cluster. So the controller will take care of creating one more pod for this deployment. So this is again
Okay.
is a single replica, but if you are dealing with deployment, it will make sure that there is a high availability is maintained.
Okay. Basically, it will helpful in high availability, right? Okay.
Yes. Okay. Any other questions? Okay. So again, if you have any questions, right, you can also put it in the WhatsApp chat so that I can address. If you have any concern regarding the course content, or if you have any questions on the demo also, you can put the question in the WhatsApp chat. And if you want to contact the Kumar sir for further, so then you can uh, contact him using this number. I will put this number in the chat. You can use it. 1 second.
Rohini, is there any chance to share the course content?
I think the content is already shared, I guess, right? Even in the WhatsApp group, if you see, there is a link for the Isha training, right? And then if you go to that website, there is a brief, like whatever the course content I have provided here, everything is there in the website. But if you want in the document itself, then I will circulate in the WhatsApp. So,
Okay.
okay, so I'm providing the number. This is the Kumar sir number. So if you like interested to continue the course, then you can call him, and like for the further processing, you can ask him. And yeah, if you have any question now, we can you can ask now. Sorry again, in between, I was not feeling well today, so I just so if you have any question, you can ask me now. Otherwise, we can. Yes, from tomorrow onwards, we will have regular sessions. So today it's the only demo session, but from tomorrow we will be having the regular sessions, that is covering the actual content of the course.
Rohini, one more question. Is there any difference from uh, other language, right? Like you're telling some other, you have developed a different language, right? So I'm looking for Java-based application. So will there be any difference in there?
So basically, for the deployment you're asking, or for the microservice application you're asking?
So
because
for
I did.
microservices.
Okay, so basically the application, it may be developed in any other languages. It's not a matter, because at the end of the day we are treating it as a microservice, and we are deploying this application on the cluster as some resource, that is either it may be deployment or pod. So whatever the application, we are going to use it, so that it is not going to, or we are not going to concern about the language which the application is using, but the only focus for the Golang here, I have told, right? So for the Kubernetes operator, so this is the Kubernetes operator. Why I have mentioned we need to use the Golang here, because Kubernetes, if you go to the Kubernetes website, and okay, this is the GitHub for the Kubernetes. Let's open it. If you see this, right, there is a 97% the Go is used here, and the shell, PowerShell, other things. But there is no other language which is used to develop this particular Kubernetes. So now I want to build something out from this Kubernetes. That is, I am extending the capabilities of Kubernetes using the Kubernetes operator. So I will provide some use case why you have to build this Kubernetes operator, why Kubernetes itself is not sufficient. So when you are building some extensibility or capability apart from what Kubernetes is providing to us, then you have to use the base language as the Golang only, because Kubernetes itself to develop it is using the Golang. So when you want to develop some capabilities to that, then you also need to use the Golang only. You can't develop using some other languages. So that is the only purpose where you are going to use the Golang. Apart from that, if you want some Java specific application, that is also totally fine. I can also work with that. It's not like I'm mainly focusing on the programming language for the deployment of the application, but it may be any application, complex application we can take, and it may be Java, or it may be Golang, or it may be Python. Still, it is able to run successfully on the cluster. There is no difference in that when you are like deploying the application. But when you talk about the Kubernetes, there I have specified you should use the Golang for development purpose. I hope that is clear. Don't worry about the languages if you don't know. Also, if you're already aware of Java, that is totally fine, because even still Java application can be run on the cluster. So there is no much worry about how I can deploy the Java, or because Kubernetes is developed using the Golang, how can I deploy the Java application on that? So it is not a problem to deploy the application. But to develop something for related to the Kubernetes, then you have to use the base language which is used by the Kubernetes. That is the only concern here. But again, we are not much going in depth towards Golang here, but I will give some use case where you have to develop this operator, and how you can develop the operator using the operator SDK framework, because this is a good framework which is available in the market, so that you don't need to develop everything from scratch regarding the file folder structure, and there are different logic you have to provide. So there is a predefined framework which is given to you, so that will help us to build the operator very fast. So that is the only thing.
Are you going to go through the CI/CD also for deployment purpose? Are you using anything?
CI/CD, I'm not focusing here. So we are just mainly focusing on the Kubernetes here. So every concept which is I have provided here, so it is directly on the Kubernetes using the kubectl tool. This is a CLI tool where I'm going to use this kubectl tool. Everything you have to do it manually, because if you don't use the kubectl tool, or if you don't do it manually first when you are learning, then you won't understand in the CI/CD process. So that is the need. And also in the Kubernetes itself, you have to learn many things. So by doing things, then only you can learn. So that's why we are not mainly focusing on the CI/CD process here, but we are just using the Kubernetes and some tools to work with the Kubernetes.
Okay.
Yes. Okay. Any other questions?
What is the timings, Rohini, for this course?
Yeah, it is 9 to 10 only because even I have many session from morning to evening. So that's why I like preferably going with 9 to 10. Even the team, even team is also suggested to take 9 to 10. Yeah. You are also available during this time only, right? Or any conflict?
No, as of now, I'm
Because,
free. Yeah,
okay,
that's not a problem. Yeah.
okay. So yeah, as I mentioned, from the morning to evening I have classes, so that's why I can't able to take it in evening or morning. So I already have some batches running currently. So yeah,
So duration, what is the duration of this course?
it is
This
30 days. 30 days.
okay.
Yeah, still if you have any question, you can paste it in chat or WhatsApp chat, and you can contact Kumar sir for the further process, whatever you have to done from the, for the institution, and then we'll proceed.
Thanks, Rohini.
Okay, if no more question, then we can drop off. Okay, thanks everyone for joining, and yeah,
Thanks, Rohini. Thank you.
yeah, thank you.